Welcome to Khetztutorials, and in this video I want to talk about contingency tables. So these tables are basically associated with two or more variables, and what we want to do is to determine the relationship between these variables and finally conclude whether the variables are independent or not. So let's say, for example, we have the weather, right? We have the weather and we have some values which give the weather basically. And over here, let's say we have the number of people who went for a swim. So you can write something like that. And if we here, we are dealing with only two variables. And now if the values actually influence each other, then these two things are basically dependent. So if we find that we have a case where people swim under certain conditions, then the values are actually dependent, right? So going for a swim or not actually depends on the weather, and that is in most cases true. But in a mathematical sense, we want to check for independence using something which we previously discussed in a previous video, which I'll link on the top right. And for independence, so for independence, the intersection of variables, let's say for example a and b, should be equal to the product of the probabilities of each of the variables. But now we want to look at this in a tabular form, but the same principle applies. So if we find that a value which you took from the table is equal to the product of values which you take from the table, which we then multiply just like that, if this is equal, or if this holds, then we know that the values or the variables are independent. And if it doesn't hold, then the variables are dependent. So let's look at an example so that this make more sense, I guess. So it's a table, I did mention that. And I'll be talking about a few more properties of the table, or a few more things that we have to look out for in the table. So usually down here we have totals. So let me fix this. Usually down here we have totals, and all the way the last column we have totals as well, and up here you expect to have your variables. So now in this example we have male, female, then green eyes, and over here we have blue eyes. So the problem statement says a group of 540 people. So we know that this is the total number of people who are involved in this test or in this activity. And these people have either green or blue eyes, and they were randomly selected. Now the task is to determine whether having green or blue eyes is dependent on gender, right? So is there a relationship? Does having green eyes say anything about your gender? That is the question right now. And to prove that, we basically have to test for dependence. Does having a certain eye color depend on your gender? So let's just fill in the values which are given, and we can find that answer, or we can find the conclusion from doing the necessary calculations which involve this. So if the left hand side over here is equal to the right hand side, then the values are independent, which means there is no correlation, or there is no direct relationship between being male and having a certain eye color, or being female and having a certain eye color. And now as I complete this, you'll notice that the total is computed in this direction for columns, and that means that over here you expect to have this total as a sum of the things which are above, or the numbers which are above, and the same holds here for the final column. And you notice also that this is the total number of people. So the sum of this row in that direction will be the total number of people, and the sum of this column in that direction will be the total number of people. So that is something to look out for. If you're ever asked to find any of these values, given the totals or given any other information, then that is what you basically use. If you sum the values in a certain direction, then you expect them to give you the total, which is at the end. So the total of this should be that. The total of these two should be that. The total of these two should be that over there. The total of these two should be that down there. Total of these should be that. And finally, the total of these two should be the total down there. And that is why we basically have this totals column and the totals row, so that everything actually checks out the way that we want it to. So now that we have the table, let's move on to questions. And then finally, we can see whether the variables are independent or not. So the first question says, if a person is selected at random, determine the probability. So the probability that he or she is a female with green eyes. So basically, this is the probability of being female and having green eyes. So it's the intersection of these two. So the person that we're looking for has these two properties. The person is female and they have green eyes. So what we do is we come up to our table and we look at the female column, and you can draw a line. Then you come to the other variable, which is green eyes. Then you draw a line across in that direction. You can do this with your eyes. Where these two lines meet, that is what you're looking for, because it's the intersection. That is the literal definition of an intersection. Where the two variables meet, that is the value that you're looking for. And now, since there aren't any constraints, the total will be the total number of people. So that would be your probability, and that is how you compute the probability. In simplified form, it should be 49 over 180. Moving on to the next question. The next question says, if a person is selected at random and they have green eyes. So now look at this. We have a constraint over here. So we're only looking at a small group of people, only the people who have green eyes. So everyone else does not have green eyes if they fall outside that total. So the person that we're looking for, let me just complete the line of the question. If a person is selected at random and they have green eyes, so this is a given. If you remember from one of the first videos that I did on probability, I talked about this symbol when I talked about notation, and I just think that on the top right. And this says something is given. So we're given that the person has green eyes. And now that they have green eyes, what do we have to find? We have to determine the probability that he or she is female. So what is the probability that someone is female given that they have green eyes? So we're only looking at this portion of the table. It is given that the person has green eyes, but we don't know if the person is female or male. But we specifically want to check for a female person. But that person must have green eyes. So it doesn't make sense for the total to be 540, because that includes people who also have blue eyes. So we're given that the person must have green eyes, and so that'll be our total. Out of the people, here's another way that you can phrase this. Out of the people who have green eyes, how many people have, or how many people are female? The answer to that is 147, which you can take from that. So out of the people who have green eyes, how many people are female? And that is what this means. And that is how you'd answer that. Right? And you can simplify this to 49 over 110. Moving on to the last question. And this is where we now start talking about the independence thing. And the question says, after analyzing the results, a grade 11 learner concludes that the probability of having green eyes is independent of gender. Is he correct? Right? So that is what you have to check. You now have to check whether the variables are independent. And for independence, you just go back to this condition. So you have to find the one and find the other, then see if those things are equal. So let's check that. We can use any of the variables, or we can use either male or female, but let's just use the female option because we've already found that. So we already know the probability of being female and having green eyes. So we've already calculated that, and that was 147 over 540 because we're including everyone who's involved. And now we have to find the probability of being female as well as the probability of having green eyes. Let me just write G. And we're going to multiply these two and see if they're equal to that. And if they are equal, then that means that the variables gender and the color of eyes are basically independent. Because for independence, A and B has to be equal to the probability of that. So now let's see, what is the probability that a person chosen at random is female? So we go down here and check this column, and the total number of females, is 240 out of the total number of people. Now, what is the probability of picking someone with green eyes? And that is that line over there. The total number of people with green eyes is 330 out of the total number of people. Now, if we multiply this, and let's just say F for this one, if you multiply these two, you should get 22 over 81. And if you simplify this, we simplified that to 49 over 180, and we can't go any further from here. This is what we get when we multiply the two. And here's the result of the previous one if we simplify it. Now, if you convert these two into decimals, then that is where we can make the comparison. This is 0.27, and the other one is 0.27 as well. So the results are the same. So multiplying each variable's probability and the intersection of the two variables, we found that that is basically equal, right? And therefore we can conclude that the variables are indeed independent, because multiplying the probabilities and the intersection of the two variables actually leads to the same thing. And so the person who made the conclusion that the probabilities are independent was actually correct. So we found that this holds, and therefore the variables are independent. And that is how you basically do such a question, and that is the reasoning behind everything that we did. And this is how you check for independence. And always look out for words which separate certain probabilities. So it's not always explicitly given to you. You won't always find the term given. They might say something like, out of the people who have green eyes, like they did in this scenario. So you have to change your totals based on what you're asked, right? Otherwise, if nothing is said about the group that you're looking at, then you consider the group as a whole and you basically look for intersections and the places where you have certain variables as true, right? So that is all from me in this video. I hope it was of value. If you like the video, just give it a thumbs up and I will see you in the next video.